Hey, it's Tony again, and I'm here to give you a really quick demo on event-driven Ansible. So in this slide, we'll just take a quick look at what that entails. So for Ansible to provide what we call event-driven automation, we really have three components that we need to understand first. The three are the event sources, the rules, and the actions. So the event source is not really the source of the event in so much as like the router, switch, firewall, server, etc. It's the source in terms of the data. So for all intents and purposes for this demo, we're using one of the more well-known brokers, Kafka. However, there are other options, and over time, you'll see more and more source plugins introduced into EDA. You can also use webhooks, which is also popular in the network domain from like controllers and other software that has that ability as well. But for devices, we're kind of limited in that regard. So on the device side, we use, or at least for routers and switches, I'm using telemetry, streaming telemetry, and that uses gRPC or GMNI, and that is unable to talk directly to Kafka. So we have like another layer, if you will, and that is a collector called Telegraf. If you're familiar with influx databases, they are the contributor of this open source collector called Telegraf. It takes in inputs, so from the devices, and in this case a router, it can take in the gRPC, the streaming telemetry, and then convert that into JSON structured data that we can send into Kafka, and then Kafka can provide a source through the plugin to the EDA server. And as we go into the moving parts here, that should become much more clear. But before we dive into the live demo, just a couple other things to understand. The second being the rules. So rules are created in terms of a rule book. So a rule book is very much like a playbook. So a playbook is a YAML file where we can take and call a module and define parameters. So a rulebook is very similar in that we read in a YAML rulebook, and those rules are processed by the EDA server based off of conditions. So if conditions are met, then that can trigger a particular action. So in this case, actions can be things like running a playbook or sending a causing a trigger to invoke a workflow in Ansible Automation Platform Controller, or what you may be more familiar with as the term tower. So we can create notifications, all sorts of things to respond to particular events. So in my opinion, this is very exciting because, just the fact that Ansible is a push model normally, or to create the ability to check on these devices over time, we tend to rely on schedulers. So now with event-driven automation, we have an actual feedback loop. So the information at any given time, in real time, these devices can send these events, and then we can respond to them and either use them in a passive way in terms of notifications, or we can, actually, invoke what I would term as, an automated remediation. So from that, let's go ahead and take a look at the demo. At this point, what you're observing is an actual rule book. Much like a playbook, it's a YAML file. And in this case, what we're doing is we're populating the required information at the top of the rulebook. And just like a playbook, right? We have hosts. So in this case, it's local host because I'm invoking the rulebook and running it directly on my laptop. So everything is sourced locally as opposed to an SSH connection to another server somewhere else. And what I'm saying is I want to take this particular source, which is Kafka, and I want to listen on port 9092. So that's the Kafka port that we can use in terms of being able to pull in, ingest that data. Now, we're pointing to data effectively through a topic. So the topic is Telegraf. And if you recall, I mentioned Telegraf is the collector. So what I'm doing is all the data that's coming to Telegraf, I'm just labeling it Telegraf, and that data is being sent into Kafka. And then the EDA server is only listening for subscribing to Telegraf topic. Now, from that, once we receive data on that port, and secondly, based off of that topic, then what we can do is we can implement a rule. So these are the conditions. So in this particular example, what we're doing is we're looking at the event that's coming in from Kafka on port 9092, labeled Telegraf, and we're looking for fields in the data. So think of it as a dictionary named fields. And then as we parse through this, we're looking for the key of new state. And if that key's value is interface notification state down, we know that on the router, one of the ports went down. So that could be caused by various things. It could be an accident if somebody had inadvertently shut the port, or it could be something else related to a hardware failure. You could have the line protocol down for many different reasons. So what we want to do is we want to respond to this by running a playbook that would give us further triage. So we can change some commands. We can do some show commands to see if that worked. And then if not, we have some data that we've collected automatically, and then we can make that information available through notifications to the IT team that's responsible for operating the network. So in order for this to work, and I had mentioned that this is running on my laptop, just to point out and to clarify a few things, this EDA server that I'm running on my laptop is based off of the developer tech preview code. At the moment, you have to run this server and install it either directly on Linux or as part of a container. And it can communicate through the rulebook and have interaction with Ansible. In this case, I have an Ansible automation controller, but it's not integrated directly into it. So that's the next step. So when we reach GA, which is it's scheduled to be for the release of Ansible Automation Platform 2.4. Currently, we are on 2.3 as the current version. That is supposed to be released sometime in May. So when it's generally available, it will run as part of the controller. So there's nothing else separate to install and run, and to manage in that regard. So at the moment, it's separate, and it is already installed and running on my laptop. But what I need to do is I need to enable it to listen to Kafka for this particular rule that is defined in this rulebook. So for me to do that, much like we have Ansible playbook commands, we also have similar Ansible rulebook commands. So let me run this one here in the terminal, and you'll see that it'll start to listen on this port for that topic. And that's what we see here. The topic is Telegraf. It's looking for interface notice state down, right? So it's just sitting there, it's listening, and it's waiting for that data. So now let's switch gears, and we'll take a look at it from the router's point of view. So here we are with router 1. And just to give you a real quick viewpoint of everything that's running before we change anything, just to give you kind of the lay of the land here. This right here is Telegraf. So Telegraf is just waiting for data to come in from Cisco telemetry. MDT is a input plugin, and then the output would go to Kafka. So we haven't sent anything yet, or we haven't caused an event yet, so it's just sitting here, it's quiet. And then once we have data come in, then Kafka will start receiving that data, and we'll be able to see that here. And then Kafka will pass that data in a format in JSON that we'll see that as well. So, and this is the Kafka viewer. So it's just sitting there and it's waiting. So one of the things here to understand is the state of the router. So let's see what the interfaces are up to. At the moment, all the interfaces are up. So what I want to do is take the loopback 0, which is the router ID for OSPF. And if that were to go down, that's bad because that would shut down our capabilities in terms of the OSPF process that's running on this router. So we definitely would want to monitor that. So that needs to be available for us. So if I look at loopback 0, if I go into config, if I were to shut this down, then that should cause an event. Now, before I do that, let me show you how that is set up in the router under telemetry configuration. So this one right here, subscription 1, it has a particular filter, and it's using XPath. So XPath is a much cleaner way to parse XML data. Well, I'm not a fan of XML data. It's really hard because of the opening and closing tags. So when you're looking at a dictionary of key value pairs, it's not the easiest thing to work with. So XPath is awesome because it gives us like a direct way to point to the data that we want to watch for an operational state change. So in this case, it's iOS from the router, it's iOS XE, and it's operational data. Upon filtering that data, the next step here is to send that data. So if we look at the receiver, we can see that it's sending the gRPC streaming telemetry to port 57,000 using gRPC TCP. So that's what we're receiving in Telegraf as the collector. Now let's go ahead and look at the router. Oops. And we can see that all the interfaces are up. We're going to select loopback 0 because loopback 0 is actually a fairly important interface here because it is also the router ID. So in terms of OSPF process, that depends on that loopback being up. So if it were to go down, the IT team responsible for the network operations would want to know that. And in this case, we can include an action that will create a auto remediation of unshutting an interface that's accidentally shut down. And if that doesn't work, it'll continue on and to observe some additional operational data to see what the state of the network interface is. So we'll see that here in a second. So let me go ahead and go into int loopback 0. And as soon as I hit this, it's going to make a change. And we'll see that trigger the event. So let me be ready to click here on Kafka so we can see that change. So hit shut there. And here we go. We can see that on loopback 0, we have the interface notif state down. And that started that kicked off a job template in the Ansible automation controller, which will, from that perspective, will run this no shut playbook from the controller. So if we take a look at the controller, I'll go ahead and jump into jobs. We can see that we just ran that playbook. And this is what happened. The playbook sent these commands to no shut the interface, loopback 0, and it also collects a diff. If we look at the before state, before we ran the playbook, what it does is it collects the state of the router, and loopback 0 was not enabled, so that's equivalent to the shut command, so enabled false. And then we can see after it's enabled true. So the no shut went ahead and enabled that interface. And then that culminates into the next piece that we see here where we wanted to validate that step to ensure that it worked. And in this case, it did because this show interface command shows us our interfaces. And at loopback 0, we can see that not only is it enabled, but it's also up and running. So if that were down, then we may want to continue to troubleshoot. In addition to that, it sent a notification. So in Slack, we can go back and take a look at that. So my Slack is actually not running at the moment. So let's bring that up. And we can see here, this was the last one that was sent, job 2072. And that brings us back to here. And we have the same information. So this is really effectively a notification with a cross-link back into the controller, so that way if we wanted to notify somebody on a network team, then they would see that the interface went down, but it's back up, and this validates that everything is okay. But if it were down, if loopback 0 was still down here, then that could invoke the need for additional manual troubleshooting, or perhaps we have additional conditions, and then we go ahead and triage more automation around troubleshooting to save time. So that's what I wanted to show you for this one. I have some other event-driven demos that I'll provide later, but I hope you enjoyed this brief demo on, no shut interfaces that shouldn't have been shut in the first place.